We're live. Alright, this is proofs. I'm going to teach you how to do proofs of for triangles. This is our first set of proofs, so you're going to kind of see how they start to flow as we go. Things that you need to have out. The reference sheet I gave you yesterday, which was basically your notes from yesterday. You're going to need that on your desk. It should be there already. If it isn't, you need it out. We are going to refer to this. The stuff at the bottom that I told you about, we're going to use this today to do our proofs.
You take them apart.
Do what you need to do. Alright, so triangle congruence. We're doing SSS, SAS, ASA, AAS, and HL. So what we're doing, it's best to read this at the top first. If all corresponding angles and sides on two triangles are congruent, then the triangles are congruent. Y'all know that. However, we can prove triangles to be congruent using fewer parts. That's what we're doing. We're going to prove some triangles to be congruent by SSS, SAS, ASA, AAS, or HL. Once we do that, then after that we'll know that all the corresponding parts on both triangles are congruent. But we're going to prove the triangles to actually be congruent first. The other thing I want to tell you too, since we're proving triangles to be congruent, your answer choices won't be AAA or ASS. Those are ways not to prove triangles congruent. So those won't ever be answers in a proof. Don't put those in a proof. I've seen kids do that before. Put AAA on a proof, on a congruency proof. That is wrong. For congruency, it's only going to be one of these five that we talked about the other day. All right. First one, side, side, side. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Yes, I agree. We're going to write that out up here using this figure over here. On the figure over here, they marked all three sides of both triangles congruent. We're just going to write it out. AB, side AB, is congruent to side DE. And then side BC is congruent to side EF. And then we have side AC, which is congruent to side DF. If that's the case, then triangle ABC is congruent to triangle DEF. My side, side, side congruency. We're going to flow through a proof and show ourselves that. I can't really sniffle, but whatever. Huh?
Why is it changing?
Oh, you wasn't done? All right, slow.
Hey.
We all don't got to put your hands on your feet.
Yeah, the ones that didn't turn it in. That's fine. Take one of these around so they know what they can go on for.
Can y'all please have these out so I can pick it up? If you finish it.
Jordan, fine. Alright, we should be ready. Sample SSS proof. So on these, we're telling you what kind of proof we're doing before we do it. But when you get to the practice, you're not going to know. So it's going to be up to you when you get to the practice to do your stuff correctly so you'll know what kind of triangle, what kind of congruency you're solving for. So in a proof, they're going to all kind of standardly look like this, except for the ones that are written in paragraph form. But most of the proofs you see will look like this. It'll be a table with statement and reasons. And they'll ask you to prove something to be true. In this case, they're asking us to prove triangle JKL is congruent to triangle NKM. In a proof, they're going to give you some information to start out with. They're literally either going to write it at the top and put given by it, or they're going to... I don't care. Let it go. I'm messing up the video. Please stop. I don't care. We'll figure that out later. You'll be given information at the top, or they'll actually give you information on the proof. Like instead of like writing that stuff out like they wrote it, they'll mark stuff congruent on the proof, and you could just go from there. That'll still be given information. If they put stuff on the proof, I mean not on the proof, on the diagram right here for you to see, That's still information that they're giving you. They didn't put anything on ours. They want us to mark it for ourselves, but sometimes they will. Alright, so everything you're doing is distracting. Can you just stop? Thank you. Segment JL is congruent to segment NM. That's the first piece of given information. Anytime they tell you something like that, you want to mark it on your actual figure. So the first thing I'm going to do is mark segment JL congruent to segment NM. On my figure, I'm going to mark JL congruent to NM. After that, the next thing they tell me, K is the midpoint of segment JN, and it's the midpoint of segment LM. It's the midpoint on both of those segments. They tell me that for a reason, because it's something I should know if that's the case. Segment JN, let's start with that one first. They're telling me K is the midpoint of segment JN. If K is the midpoint of segment JN, what should I know about that segment? Somebody in here knows. Say it again. What's congruent? Everybody would say they're congruent. Be specific. Say it louder. Yeah, JK and KN. Or in this case, we're going to say JK and NK. We have to be like do it kind of in order when you say it on here. But she's right. You should know if K is the midpoint of JN, that JK is congruent to NK. Because they said K is the midpoint. They also said, though, K is the midpoint of segment LM. If that's the case, if K is the midpoint of segment LM, we should know something about LM. We got to name it. LK and MK. LK is congruent to MK. Y'all already doing better than last period, which is a good sign. Those are things we should know just by reading the top. I haven't even touched the proof yet. But just by reading the top up here, I should know these things. And just by reading the top, I've already kind of marked up everything I need to mark up to be able to see it. But you see me marking as I go, though. This is what you have to do. After that, I'm going to read through my proof and try to figure out what these reasons are that are missing. So on this one, all my statements are there, but my reasons are missing. And it depends on what they want you to answer. Sometimes you'll have all your reasons, all your statements will be missing, or it'll just be a mix. Or sometimes they'll just ask you for one little missing piece of the proof. I can't tell you what they're going to ask you. I just want to show you how to do a proof so you'll know how to answer anything they want you to answer. All right, so starting out. The first thing they tell me in my statements is JL is congruent to NM. I've heard that before. You should have heard that up there at the top. My question is, what reason would you give for that? And this is when you want to go to your reference sheet over here. They said side JL is congruent to side NM. Go to your reference sheet over here and look at reasons sides might be congruent or congruent. Out of those reasons, which one would you use to tell why JL is congruent to NM? Jackson? It's given. Literally written up there at the top. Given. They told us that. We just write given, though. We don't write it's given. But given. Line 2. The statement is K is the midpoint of JN and LM. What is the reason we know K is the midpoint of JN and NM? Go ahead. LM. That is also given information. This was stuff that was told to us at the top. Then after that, line 3 says JK is congruent to NK. Go back up there and look at it if you forgot what it was. JK is congruent to NK. They want to know the reason. We know that. Jordan, you think you got a good reason for that? That is the correct reason. This is the definition of a midpoint. We call K a midpoint, so we split and said JK is congruent to NK. Definition of a midpoint. Of midpoint. Then line 4, LK is congruent to MK. Go ahead, Jasmine. This would also be definition of a midpoint. You're doing miles. I'm going to kind of keep saying because I got frustrated last period. You're doing miles better than the other class. Definition of, all right, guys. We'll see. Definition of a midpoint. So on this one, we had to mention it twice because we split two different segments. We split segment JN and we split segment LM. Anytime you split two different segments using midpoint, you're going to have to mention it twice in your proof. And you're going to have to name the segments that were split. And then we also, they said these were congruent, but we've already marked them as congruent up here, so we don't need to go back and do it again. Anytime anything is congruent to something in your proof, you need to go mark it in figure. After you do that, now they say a triangle JKL is congruent to triangle NKM. This is the time for us to tell why we know those triangles are congruent based on what we did in our proof. And this is where we will put what, Jasmine? SSS. If you mark your proof correctly, you'll be able to see it easily. This is side, side, side congruency. That is how you do a proof. We're going to keep going, though, because there are all kinds that we can do. Not a bad start, though, kids. We're going to speed up as we go. We'll get faster. The second one, side angle side. If two sides and an included angle of one triangle are congruent to two sides and an included angle of another triangle, then the triangles are congruent. If that's the case, you see a sample side, angle side right here. We're just going to write it out. If side AB is congruent to side DE, and then angle B is congruent to angle E, and side BC is congruent to side EF, then triangle ABC is congruent to triangle DEF. All I'm doing is using the picture to write this. Slide it just a little bit. I'll leave it up there for the kids who write slow. Number 2. This one. They start out by telling me, well, let me tell you what they're trying to prove first. We're trying to prove triangle JMN is congruent to triangle LNM. To prove that, we need to go through and prove it using one of our congruencies. We're going to use the information that's given to help us out. They said segment JM is congruent to segment LN. Then they say angle JMN is congruent to angle LNM. So let's mark that stuff first. Segment JM is congruent to segment LN. We want to mark that on our figure. JM is congruent to LN. After that, that's why I get worried with y'all doing this. We have to mark our angles that are called congruent. I get scared when y'all have to mark angles because y'all be doing anything, and this is where y'all start messing up at. They said angle JMN is congruent to angle LNM. Angle JMN. Find that angle and mark it correctly. I know most of y'all gonna wait on me, and that's what got me worried. JMN, the middle letter is where the angle actually is. The other two are just guides. JMN. JMN is this angle right here. And then angle LNM. LNM, middle letter is where the angle actually is. The other two letters are just guides. LNM, that angle right there. They told me to mark those congruent. Alright. From there, I'm going to read through my proof, get the rest of the stuff, and figure it out. In the proof, you got reasons missing and you got statements missing, but we can do this. Line 1 says JM is congruent to LN. You can have your hand up, so go ahead. That is given information. They told me that at the top. We already don't mark that too on our figure, because they told it to us. Line 2 says given. What's the missing statement? Go ahead. Not you, Jasmine. The other given information that was given at the top, we already marked that too, so we good. Something new, line 3. They say MN is congruent to NM. The reason they say that is because the two triangles are connected right there. I'm sure everybody can see that. They share that side, right? MN and NM. My question to you is, if they share that side, what reason would you give why you know those sides are congruent? Look at your reference sheet. What reason would you give that those sides are congruent? Well, yeah, Ben had his hand up, but I'm assuming that's what he was going to say too. Yes, reflexive property. This is what it looks like. It's your first time seeing it, but it won't be your last. Reflexive is one of our favorite things to use on these. Reflexive property. And sometimes they write it all the way out as reflexive property of congruency. Don't be confused as they do. It's the same thing. Reflexive property is when they share something. They share a side here. MN and NM. But you should have noticed that they named this. They didn't name them both the same way. And they did it on this one for a reason. And I can try to explain it to you, but you'll figure it out as you go along. Kids were figuring it out today. So these two triangles, they're connected. And it's almost, if you look at it, we haven't done that unit yet, but once we do it, you'll really understand. It's almost like this first triangle is rotated around, and that's where that second triangle landed. It's almost like a rotation. Like the first triangle got rotated and 180 degrees, and this triangle landed over here. The reason I say that is what happens when you rotate the triangles like this and put them on each other. The side that they share kind of gets reversed of each other. Even if you look at it, the way they named it, they named the first triangle JMN. You would have to name the second triangle LNM if you want your statements to be correct. And that being said, even when you look in the statement of the triangle, MN matches up with side NM on the other triangle. Y'all follow that? You see how the letters are reversed? It's because MN matches up with NM. And that's why they wrote it like that down here. You won't always write it this way though for reflexive. If it's a flip, then you're going to write them the same way. You'll see on the next problem that we're going to write it differently. What's up? You got? I didn't hear anything you said.
Like how we did last time, we highlighted it and put 2 lines in the middle, not in.
Yeah, we're going to do that. I'm not done yet. I'm just talking. I just want you to understand why they wrote it this way. And we're going to write it differently on another one. And you have to be mindful of how you write this, because if you write it wrong, it's going to be wrong. Alright, so on this one is, and you can just use the statement, it'll help you. But it's MN is congruent to NM, and it's reflexive property. And like Jordan said, we need to mark that because they call it those two congruent. So I'm going to mark it with 2 markings here because I already used one for one of my sides. Once you mark this correctly, it's obvious what they're trying to show you, even though they already told us what this was going to end up being. What is it, Jasmine? Huh? Girl. Side angle side. Will y'all stop abbreviating and making new words? The ASA and the AAS and
ASA.
whatever.
ASA, SAS.
Oh, God.
The word I can't say.
Alright. Next one. This is angle side angle. Alright, at the top, if two angles and an included side of one triangle is congruent to two angles and an included side of another triangle, then the triangles are congruent. So, we're just going to show that over here. They got it marked angle, side, angle over here. We're just going to write it out. Angle A, congruent to angle D. Side AB is congruent to side DE. Then angle B is congruent to angle E. And that is the case. You got angle, side, angle, and the triangles are congruent. ABC is congruent to DEF. We done went through two already. I meant to tell you too. Like, this, and it's probably the only thing I want. I do not. There's no performance matters attached to these, even though it's practice and home learning. I grade these by hand. Main reason, because I want to make sure you mark your figures up correctly, and I want to see that you did the stuff correctly. I don't put these on performance matters. So we're gonna get some more tomorrow proofs. We're gonna finish the ones for today and the ones tomorrow, but you'll turn that into me by hand. I'll grade it by hand. That being said, when I go to grade your proof, the first thing I look at is, did you mark your diagram up correctly? If that's not marked correctly, I know I don't even need to waste my time, because if that ain't right, then your answers can't be right unless you copy from somebody else. So that's the first thing I look at. If you don't have it marked, I'm just going to move on. I'm showing you how to mark each one as I go. All I'm doing is reading through and marking up the stuff that's supposed to be marked. That's the only way you can get the right answers anyway. So that's how I know some of y'all be copying. Y'all be having, kids be turning in this junk, don't have nothing marked on here, but they be having just letters and answers on their paper. How? I can't even do it like that. Alright. Sample ASA. This one, given SQ bisects angle RQT and angle RST. Prove that triangle QRS is congruent to triangle QTS. Please make me proud. They made me so mad last period. They figured this out in a second. I need y'all to too. The first thing it tells me is SQ bisects angle RQT and angle RST. So SQ, that segment, it bisects two separate angles, RQT and then RST. Let's talk about RQT first and what happens. They're saying that this segment came through and split angle RQT, bisected it. If that's the case, what should I know? Be specific. You got to name it. What should I know? If angle RQT is bisected by SQ. Let's go, Rodriguez. Yeah, I agree. Only thing I'm gonna do is, I don't know why, and it don't really matter. I might use it your way. It don't matter. I like the way you named it. I'm gonna go your way. We just been naming it the other way the whole day. She said angle SQR and angle SQT are congruent. They would have to be. I'm gonna mark them for you. SQR is this angle right here, and then angle SQT is this angle right here. She said those two angles have to be congruent. That is true. That is the definition of an angle bisector. Those two angles have to be congruent if SQ is going to be called an angle bisector of RQT. It's split it in half. That being said, on the other side, let's say angle RST is bisected as well by SQ. So what should we know there? What angles? You just saying. You named the first one, right? So say it louder in front of the beginning. Stop saying it to me. Say it to them. She said RSQ and TSQ would have to be congruent if SQ bisect an angle RST as well. I'm getting all this just from reading that top part and understanding what they're telling me. They're telling me that SQ bisects angle RQT and angle RST. Just based off knowing that, I should be able to mark that stuff congruent on my figure. What's up? Yeah, we'll get there. Let's just do one thing at a time. I'm taking it slow with the children. That's all from given information. I haven't even read through my proof yet. From the given information, I marked all that on my figure. Now, I'm ready to read through my proof. Line 1. SQ bisects angle RQT and RST. Ariana, what would you put there? Ariana. The first line of the proof, it says SQ bisects angle RQT and RST. What would I put there for my reason? Given. Y'all told her or she knew? Alright. That's given information. Oh, well, you should have been said it. Line 2. Definition of an angle bisector. I'm going to come back and let Rodriguez do that. Rodriguez, what should go there for my statement? Say it again. Oh, now you're renaming it? That's fine. Go ahead. Say it loud. I can't hear you. Yeah. Now, earlier when she named it the other way, but she's still naming it right. RQS is congruent to TQS. Earlier you said SQR and SQT. Yeah. Same thing, you just reversed it. That's fine. But that's the way we've been naming it all day, this way. All right, what's up? What? I was going to give you the opportunity to answer that after I posed the question. On number 3, angle RSQ is congruent to angle TSQ. And my reason is missing, but Jasmine has just said it, so say it again, Jasmine, out loud to the children. This is the definition of an angle bisector. This is just like on that midpoint one. We mentioned 2 angles being bisected, so we have to mention definition of an angle bisector twice. If we only mention one angle being bisected, then we only mention it once. But since we mentioned 2 different angles being bisected, we have to mention this twice. And we've already marked both of these things congruent up here, so we're good. Next line, it says the reason is reflexive property. Our statement is missing, though. You're not going to answer it when I got to get these other kids jumped off. Mike, what you think? Bryce, stay alive. I'm thinking about you. I'm coming. SQ is congruent to what? So say it. So SQ is congruent to what? SQ. Thank you. I'll overdo this, Mike. Well, I'm going to just do QS, though, because that's the order it's in on there. It don't matter. As long as they're in the same position, you're good. You can say SQ is congruent to SQ, or you can say QS is congruent to QS. This is one that you don't want to flip them, though, and I'll explain why, of course. I'm going to do QS. That's what we've been doing all day. QS is congruent to QS. But you can say SQ and SQ. That won't be wrong. What will be wrong is QS and SQ. If you do that, that will be wrong on this one. Reason being, this one is not a rotation of the figures. This is a flip of the figures. When you name these, and they named them, QRS and then QTS, you see the Q and S are in the same position on both. It's QS and then QS. Oh, we need to mark that. So we said those 2 sides are congruent. They share it. Mark that here. And then you will be ready to read for your congruency. Triangles are congruent because of what? Go ahead, Jasmine. Angle, side, angle. I don't know what ASA is. Yuck. Next one. Angle, side. What's up?
So, for the reflection property, it wouldn't be QS just QS itself.
QS and it's congruent to QS.
Yeah. It wouldn't be QS.
No. And I was trying to show you the difference between this one and the last one. Look at this one. So this one's more of a flip of the triangle. The triangle's kind of flipped. Just flipped up. On this one, it was a rotation of the triangle. They didn't flip. It was a rotation. They're almost like this triangle rotated around over here. That being said, when you name it, you have to call this one JMN, and then this one will be LNM. So when you name the second one, it's almost like the M and the N flip. And it does. You even see it in the statement. It's JMN, and so it's MN, and then it's LNM, and so it's NM. So it's MN and NM. You follow me? Then in the other statement on this one, the Q and the S were in the same spot on both. And they weren't flipped. You feel me? Yeah. Angle, side. If two angles in a non-included angle, or non-included side, of one triangle are congruent to two angles in a non-included side of another triangle, then the triangles are congruent. The image is showing us what we need to write. I'm just going to write it. Angle A is congruent to angle B. Angle B is congruent to angle E. Side BC is congruent to side EF. If that's the case, then the triangles are congruent. ABC is congruent to triangle DEF. Yup. Alright, let's do one. We're almost there. We're moving all right. What's up, Dad? Like I said, I don't like talking so much, but I want to make sure y'all have enough examples. Because one thing I can tell you is with the proofs, I can show you 20 proofs, and I'll still never know what they're going to ask you on a test. But the one thing I can do is start to get you used to like kind of just how they flow and what information needs to be put in. So you could probably figure a lot of it out on your own. But I just kind of want to give you as many examples as I can so you can feel more comfortable when you see a proof and be like, you know what, I can probably figure some of this out on my own, just working my way through. But it don't matter if I give you 20 proofs, I'll never know the exact proof they're going to show you on the test. They're so wide ranging. I just need to show you the concept so you can feel that. What's up? Maybe. I don't know. No? Your first set of angles you marked wrong. Alright, next one. This one, it says given YZ bisects angle WYX. Then they just tell me that two angles are congruent. Angle YWZ is congruent to angle YXZ. And then they want me to prove triangle WYZ is congruent to triangle XYZ. Alright, so I'm going to go through and I'm going to handle my given information first and mark what I can on my proof. Given up here, it says YZ bisects angle WYX. Angle WYX is this angle up top right here, at the very top. WYX, that big old angle, that big obtuse angle. They said YZ, this segment comes in and bisects that angle. If that's the case, what should we know? What's congruent? Y'all was saying it's congruent. What? Be specific. What should we know? Somebody, and not the same voices I've been hearing. We ain't no sides. This is an angle being bisected. Angle WYX is being bisected. What should I know? Still naming sides. That don't make sense to me.
Okay, angle W and angle X.
Angle W, wrong. No.
Don't like
No. Y'all are letting 3 people make all the answers. Ben, let's hear from you though. Go ahead. No, Ben, they already told me that right here. I haven't even got to that yet. That's what they told me right here, Ben. That's not what I should know from this. I'm asking y'all, they said YZ bisects angle WYX. What should I know?
Angle Y, WYZ is equal to XY.
Say it again, Ben. Yeah, that's it.
Angle Y,
Nope.
WY
Angle WYZ, which is this angle right here.
is congruent to angle XY.
I should know that's congruent to angle XYZ.
Didn't he say it already?
No, he said that completely wrong the first time. The first time he said this, which is another set of angles entirely. Angle WYZ is congruent to angle XYZ. That is what we should know by them telling me that YZ is a bisector of angle WYX. It split the angle in half. So I can mark those two halves congruent. I hope y'all start to figure this out. It ain't gonna change. You have to do it on your own. And this is why we talking about. That's why I have kids be bad at it, because y'all can't do these little simple things. After that, then it tells me angle WYZ, I said that wrong, YWZ is congruent to angle YXZ. YWZ is this angle right here. They say that's congruent to YXZ, which is this angle right here. They're just telling me that. Give me that information. You see I'm doubling up. I hope y'all notice that as I start to mark more angles, I double up. I'm not marking all my angles with the same amount of markings. Alright. That's all the given information. Now I can flow through my proof. So on line 1, the statement is missing, but the reason is they're given. You might want to be careful though. You might want to look at some of the other stuff too. What do you think should go there, Peyton? That's two different things. Why are you reading all that? What should go on line 1? That's two different things. There's a comma separating it. Look at line 2. You good? Don't stress out. I want everybody to pay attention to this. Perez, what you think should go on line 1? Yep. Angle YWZ is congruent to angle YXZ. So what I want y'all to pay attention to is what the proof is doing. Sometimes, and this is true, all given information that isn't in the order that they want you to write it in or in proof. It depends. Read through the proof and see what was already written in there. Like naturally, y'all, because we've been doing it on the last 3 problems, y'all will want to put this information in first, but it's already written on line 2. So you can't put it in there twice. So if this is given, then you need to put the other piece of given information there. And then on line 2, it says YZ bisects angle YWX. Why is that, Peyton? Girl, what's the reason? Y'all are stressing me out. What reason should you put for line 2?
Oh, it's given. I didn't know.
I wasn't trying to do nothing crazy, man. Alright. Line 3. Missing is the statement, but they tell you definition of an angle bisector. Rodriguez, what would you write on line 3? Thank you. Angle WYZ is congruent to angle XYZ. This is what Ben told us earlier. We already marked those congruent as well. That's the ones we marked with Ben. So our 2 sets of angles, we already have them marked. We just had to write them in. Line 4, YZ is congruent to YZ. Bryce, what you gonna put there? Don't talk to him. I heard you. Leave him alone. Reflexive property. Only thing is, you got to remember, and I forget to do this sometimes, they call the side congruent to a side there. Anything they call stuff congruent, you need to mark it on your figure. So YZ is congruent to YZ. Let's mark it. Once you mark your figure up correctly, if you do it correctly, it should be obvious to you what they're trying to show you. Triangle WYZ is congruent to triangle XYZ by which congruency? What?
AAS.
Yeah, AAS. You better not get it wrong. It's saying sample AAS proof. Alright. Last one. Well, that ain't the last one of my notes. I'm going to help y'all with some on the thing too because I don't trust y'all. Y'all know that. I don't. Last one, HL, right triangle congruency. HL. If the hypotenuse in the leg of one right triangle is congruent to the hypotenuse in the leg of another right triangle, then the triangles are congruent. Alright. So on this one, real quick, just writing the stuff in using the triangles. It says if, and they got the hypotenuse first, so if BC, our first hypotenuse, is congruent to EF, our second hypotenuse, then and leg AB is congruent to leg DE, then the triangles are congruent. Triangle ABC will be congruent to triangle DEF. Only thing I want you to remember though, just because you see right triangles doesn't always mean it's going to be HL. It could still be side angle side or something else. But for HL, it has to be the hypotenuse and a leg marked congruent. But obviously this is an HL proof, so you know it's going to be HL at the end. Alright. Reading through. Given information. And y'all should know these symbols. MP is perpendicular to LN. MP is perpendicular to LN. Then they tell me ML is congruent to MN. This is given information. Then we prove triangle LMP is congruent to triangle NMP. Now, I had this in second period and it went completely right. Last period went completely horribly. I'm going to ask you an easy question. You better give me the right answer. They told me MP is perpendicular to LN. So they're telling me segment MP is perpendicular to LN. That's cool. What should I know about perpendicular lines? They do what? No. They create what? How about I ask you that better? Thank you, Ben. Save the day, because it was about to go horribly awry in here. Perpendicular lines create right angles. Y'all should all know this. Okay. Well, all 10 of y'all that said something should have said right angles. Perpendicular lines create right angles. Thank you, Ben, for saving the day in here. I was about to get mad. Alright. That being said, since they say MP is perpendicular LN, they already indicated on here with one. Sometimes they don't, though. They already put a right angle box in here, but we're going to put both in just so we know for sure. There's right angles on both sides. Here and here. After that, segment ML is congruent to segment MN. We're going to mark that on here too. ML is congruent to MN. This is all given information that we're just marking in on our figure. Then from there, we can flow through the proof. Let's start. MP is perpendicular to LN. What is the reason I know that? That was given. They told me that at the top. Listen to line 2. People been making good decisions on this today. I think I've just been doing well with y'all. Line 2 says angle MLP is congruent to angle. Oh no, it says an angle MPN. Let me read that right. Are right angles. So MLP and MPN are right angles. What reason would you give for that? Oh, good job. You got to say it louder though.
Definition of perpendicular lines.
Make it make sense. They just mentioned perpendicular. These two lines were perpendicular up here. Obviously, you're going to have to say something about that. This is the definition of perpendicular lines. Perpendicular lines create right angles. I'm going to abbreviate perp though. By now we should all get line 3 right. We're going to go back to Bryce and make sure he can write it now. Bryce, line 3. Reflexive property. What's the statement? Say it again. Look at the statement up here, Bryce, and decide which way you should write it. You stuck, man? All right. Leo, how would you write it? Say it louder again. MP is congruent to MP. Yeah, you don't want to flip this one, Bryce. Yeah, it just flips over. It's not a rotation. So when they name it, they're just going to name it the same way. They named it LMP and then NMP. Alright, and then it's way down here, but given what's missing. Go ahead, Jasmine. ML is congruent to MN. Oh, the pen is dying again. Oh, we forgot to mark. See, that's why I told you I forget sometimes. We forgot to mark MP congruent to MP. Please don't forget that. Here. Double up. And then from there, now we're ready. Triangle LMP is congruent to triangle NMP. Go ahead, Perez. HL. Throw it and keep it. Throw it. I don't care. I don't want it like that. It's not one of my good pens. Is that even my pen? Oh no. Y'all want a pen? Alright. Like I said, I don't trust y'all. So I'm gonna do a couple more with you. Make sure we on point. But we're gonna do these together for real though. I'm gonna stop talking as much. Number 9 is the first one you see that's actual proof. Once the rate is y'all just identifying the things again. First proof that you actually see. Number 9. Let's go through that one together. Side AB is congruent to side CD. Side AB is parallel to side CD. D is the midpoint of BE. It tells us all three of those things. We need to indicate all that on our proof, on our figure. I'm going to start with side AB is congruent to side CD. Y'all should know how to easily mark that. I say that, but I had kids last period looking stuck. AB congruent to CD. Then they tell me AB is parallel to CD. I'm going to mark that too. Parallel arrows. Here and here. Just telling us the sides are parallel. When you go to read your congruency, though, do not count parallel as a side, marking a side congruent. That's just parallel. That's not saying the sides are congruent, but these sides are congruent. But sometimes we'll have parallel markings on there, and kids will be reading those as congruency. No, that's just saying stuff is parallel. Alright. And then it says D is the midpoint of BE. Somebody who's been quiet. Somebody, let's see. Ro, there you go, Elizabeth. Yeah, you knew it was coming. D is the midpoint of BE. If that's the case, D is the midpoint of BE. What should we know, Elizabeth? I'll say it again. If D is the midpoint, look up here. Look up here with me. If D is the midpoint of segment BE, what should we know? Oh, you want to answer it? Okay, Ariana. Yes. If D is the midpoint of BE, what should we know? You can't let all the same kids answer the questions. I don't want you. I want somebody who ain't said nothing. About to call Brennan next. Yeah, I know you know. They need to know. Go ahead, Dennis. Hit them. Girl, what is congruent? Yeah, BD. On this one, you would say DE, though. Because of the way the triangles are going, it would be BD and DE. We should know that just from them saying D is the midpoint of segment BE. We should just know that. And we should be able to mark that without even looking down here in our proof or anything for any help. Alright, now we're ready to go through. Line 1, given. Go ahead, Peyton. What you gonna put? Yeah, AB is congruent to CD. I'm interested to see if you're paying attention, though. Line 2, what would you put as a given? Brennan?
AB is parallel.
No, sir. The reason you won't put that, because if you look at line 4, it's already written in the proof. So it shouldn't go there. Well, obviously y'all know we'll go there now. Go ahead, Denicia.
Is it BD is congruent to BE?
What? No.
I don't know.
Go ahead, Peyton. D is the midpoint of BE.
Okay, but
Given information, girl.
okay, but look at this. Oh, never mind. I just
Yeah, you missed it. I got you. You got it now. Okay, that's good. I'm doing this too because we want y'all to see that given information is not always in the order that it should be written in the proof. You have to kind of flow through the proof and figure it out. Now that we mentioned that, though, D is the midpoint of BE, and that was given. Look at line 3. They want us to mention definite. Well, they said definition of a midpoint. So what statement should go there? Say it louder. Go ahead.
Side BD is congruent to side DE.
Yes, ma'am. And we already marked that. So that's good. Everything we've written, we've already marked up. That we good. And then line 4, AB is parallel to CD. Reason? No. Given.
What is that?
It was given.
My bad. What is that?
That's something else. That won't be used here. Alright. Next thing. On line 5, it says angle ABD is congruent to angle CDE. So they're telling me two angles are congruent. On this, I don't know a reason yet. But I guarantee you when I mark it, it should be obvious to me. But you got to mark your angles correctly. They said angle ABD and angle CDE. You need to mark those two angles correctly or you won't be able to see it. Follow the letters, middle letter. ABD, this angle right here. CDE is this angle right here. We're able to say those two angles congruent mainly because we know these sides are parallel. My question to you is, if that's the case, those sides are parallel, we know those two angles are congruent because what is their relationship? That'll be our reason. No. You said it, I'm waiting on somebody else to say it. What you gonna say, Callie? You have your hand up earlier?
Oh wait, for 5, I put given. You put the
Not 5, no. Anybody got something else? Well, okay, go ahead, Denicia.
Corresponding?
They are corresponding angles.
Oh, I put given because it says that they're parallel. So
Well, they didn't give you that. They gave you parallel. That you're going to have to infer from that being parallel. So you're going to have to say that those are corresponding angles.
okay.
Yeah. Given information is literally what is given up top. This stuff. What's up? Y'all should recognize those as corresponding angles.
So if it's something that you can infer from something that's given, it's not given.
Yeah, it's not given. Yeah, no. What's up, girl? Oh, yeah. So this is one of those ones, I don't tell you anymore. You're going to have to mark your figure up correctly and figure out what the congruency is. But Jasmine is ready to tell us. Triangle ABD is congruent to triangle CDE because of what, Jasmine? Side angle side. If you mark it correctly, you will see it. If you don't mark it correctly, you ain't gonna see it. What's up? I got one more. I told you I'm going long today, but I need to. So I want to put that much work in tomorrow. It's the last one, I promise. Number 10. I'm going right into it. JK is parallel to LM. JL is parallel to KM. Prove the triangle JKL is congruent to triangle MLK. First thing we want to do, mark our given information. Given, they told me JK was parallel to KM. I'm just moving them because it's out the way. What's up? Hold on. Let me go through, Jan. Then JL is parallel to KM. So JL up here. But since I'm doing parallel this way, I need to do 2 arrows showing that it's not parallel to the other direction. And then 2 arrows down here. There we go. Alright. That's the given information, so we can flow through now and fill in our stuff. Statement 1, obviously, the reason for that is what? Given. After that, this is where we're going to have to start marking some stuff. The next thing, statement is angle JKL is congruent to angle MLK. If you mark it correctly, I promise you'll see it. You got to mark your angles correctly, though. JKL, mark that angle correctly. Try not to wait on me either. I want to make sure y'all know how to mark your angles. That's going to be the issue tomorrow and as we move on with proofs. When I come around, I mean, Mr. Silver come around and you be like, I need help. The first thing I'm going to ask you to do, mark your angles correctly. I'm going to just see if you can mark angles. That'd be the issue. Kids don't know how to mark their angles. Angle JKL. You should have marked this angle right here. Angle MLK. You should have marked this angle right here. Once you mark your angles correctly, it shows you what you need to know. And you don't even have to look at the reference sheet if you don't want to. You should know why those 2 angles are congruent. Especially if they call these lines parallel. If these lines are parallel, why are those 2 angles that we just marked congruent? Go ahead. Say it louder for the children. Alternate interior angles. I told y'all all this stuff coming back, and we ain't gonna get rid of it. Y'all thought we was outside all them weeks for nothing? I ain't think so. We gonna keep using this. Alternate interior angles. And then the other pair of angles they call congruent are JLK and MKL. The best thing I can do for myself is mark it on the figure and see what it looks like. JLK or JKL, I said that wrong. JLK, I said it right. JLK is this angle right here. MKL is this one down here. I'm doubling up now. It's a different set of angles. Once you mark it, it should be obvious to you again what they're trying to show you. We're going to come back to Dennis. Go ahead. Same reason. Alternate interior angles, just the one on the other side. After you get that, they ask you about reflexive property. Let's come back to Bryce. It's going to be his thing, man. Bryce, reflexive property. What's our reflexive on this one, man? Good, Bryce. You look shaky, but you got it right. KL's congruent to LK. We need to mark that too, Bryce. Mark it on our figure. We call those sides congruent. We're going to mark it right here. If you mark this up correctly, you should see what we're trying to get you to see. Do not read parallel as side markings. Those are not side markings. Ignore the parallel stuff. You only read angles and sides. Bryce, what you see? What congruency do you see? We're ready to tell why the triangles are congruent, sir. Yes, Bryce. God damn it. The same 5 people. No. Somebody knew. Oh, I wouldn't even dare. I was gonna ask Jamie. I'm scared. Mia, what congruency you see? We marked it all up. Did you just say ass? Girl, I told you ass ain't a way to prove congruency. No new hands yet? Ariana. Damn it. It's the same hands. Go ahead, Mike. Angle, side, angle. Yeah, Leo did. I was going to go to him, but then Mike popped up. And then Elizabeth popped up. Y'all been answering all the questions. I'm trying to get other kids to answer stuff. Alright, sorry for being long-winded. I apologize, but I needed to give you that so you can have a good set of notes to roll with. Thank you for listening.